All right. Hey, everyone. Welcome. It's Monday. It's reInvent. It's Vegas. You all refreshed. You're all, still fresh. It's not Thursday. We're ready to die. But glad to have all of you here. It's really great to be with you. My name is Jeff Bartley. I'm a principal product manager on the AWS DataSync team, and I'm joined today by Samuel Sousa, who is a solutions architect here at AWS focused on storage, as well as Jeff Lee, who is an associate director of cloud architecture at Foundation Medicine. He's going to talk to us a little bit about how Foundation Medicine has been using DataSync to help with some of their challenges in moving data. And so great story that he's got to share with you. Really excited to have all of you with us. So we're going to focus on AWS DataSync today. We're going to start off real quick with an overview. So I'll give a quick overview of the service, what it is, how it works at a high level, and then Sam is going to go into a deep dive of DataSync, really talk about what its capabilities are, what its features are, some of the things that you can do with it. And then we'll turn it over to Jeff Lee, who will tell that story about Foundation Medicine and their data transfer utility. And then I'll do a quick wrap up. And at the end, we'll do some Q&A off stage right over here. So if you've got questions, you can feel free to meet us over there and we can answer any questions you may have. So if you've ever tried to move a lot of data at scale, you know that it can be challenging. And when I talk about a lot of data, we're talking about hundreds of terabytes, even petabytes of data, millions or even billions of files. It's a big challenge moving that much data. There's a lot of things that you have to think about, a lot of things that you have to prepare for. If you're doing it on your own, you're likely going to be building and deploying your own scripts, managing software, dealing with those challenges. You very much want to secure that data. Anytime you're moving data, whether it's over the network or otherwise, you want to make sure that data is secure. So you have to think about how am I going to encrypt, and also how am I going to verify my data. Over the years, as I've talked to customers, I've been working with AWS DataSync for a number of years now. I've talked with many customers who went out, they built their own data movement to move their data from one place to another. And the one thing that they forgot to build in was automated data checking. And so the best that they could do is go back and kind of spot check the data and hope, we hope that what we spot checked really means that everything went through. So validating data is a big thing that you need to think about. You also need to think about recovering from errors. When everything's running smoothly, that's great, but nothing ever goes smoothly, right? Errors pop up. You need to think about how am I going to recover from errors as they're happening, either during my migration or during my data movement. And also thinking about things like network availability. How much bandwidth do I have? Do I need to share my bandwidth with other people who might be using it? And then at the same time, getting the best performance you can possibly get. So these are a lot of the challenges that a lot of our customers face when they approach their large-scale data migrations. And DataSync was built to address a number of these challenges. So first off, we were built to be fast. So under the hood, we use a custom protocol that transfers data in parallel to maximize bandwidth and to maximize performance over the network. We have customers today moving up to 100 terabytes a day or more using DataSync. And we always do incremental copies. That means we're only transferring the data that is changed between the source and the destination. DataSync's built to be easy to use to address a lot of those challenges that I was talking about in that past slide. So we have built-in scheduling of transfers, so you can schedule them to occur on a regular basis, hourly, daily, weekly, whatever may work for you. You can also throttle bandwidth, again, to maximize the usage of your network availability. We also offer filtering, so you can filter by name patterns and control what it is that is being transferred. DataSync is built to be secure, both secure and reliable. So we have end-to-end encryption, both in flight and at rest. We also have end-to-end byte-for-byte data validation, and so you can be assured that your data is transferred properly. And then we also offer VP endpoints with private links. So for customers who have a need to be able to move data privately, maybe they don't want to send it out over the internet, they want to keep it within their private network, you can do that using DataSync. But whether you use the public network, whether you use private link, all data is encrypted in flight using TLS. It's fully managed, so we're integrated with common AWS services as you would expect, like CloudWatch and CloudTrail. And we also we simplify the connection and transfer of data into storage services like S3 EFS, and FSX. So we remove some of the common challenges of connecting it into your network and mounting file systems and things like that. We take care of a lot of that for you. And finally, it's designed to be cost effective at 1.25 cents per gigabyte of data transferred, and there's no minimums. So these are kind of the 4 use cases that we see our customers using DataSync for again and again and again. So the first use case there is really for customers who are looking to migrate their applications into AWS. Those applications frequently have shared data or some kind of local data store that they need to move along with the application itself. And so they'll use DataSync to migrate their data associated with their application up into AWS. We also have customers using DataSync to archive their cold data. So a lot of that data that's out there on file systems and object storage systems is really cold. Think about that PowerPoint that you built 3 years ago that you haven't touched since, or that Excel spreadsheet that the finance sent you 2 years ago. It's sitting in your home directory somewhere and you never looked at it, right? A bunch of cold data that's just sitting out there, but it's possibly sitting on tier 1 storage that's taking up valuable space. So a lot of customers will use DataSync to move that data out of that expensive tier 1 storage and into something more cost effective like S3 Glacier or Glacier Deep Archive up into the cloud, enabling them to not only save money on their storage, but also to free up on-premises capacity. And then we also have customers using DataSync to replicate their data. So in these cases, they want to keep their data maybe on-premises or in other locations, but they want to make a second copy of it in the cloud. So we have a lot of customers using that scheduling capability that I talked about to run DataSync on a schedule and replicate their data up into AWS. And then finally, for this last use case, we have a number of customers using DataSync to move data on a regular basis. So you can think of use cases like Jeff's going to talk about where customers might have genome sequencers on premises that are generating data. They want to get that data up into the cloud and do the processing on a regular basis. And they're using DataSync for those ongoing data transfer workflows. So what are some of the things you can do with DataSync? And Sam's going to dive deeper on these, but just at a high level. So first off, a lot of our customers using DataSync today to copy data between their on-premises environments and AWS. And the keyword there is between, because you can use DataSync not only to copy data up into the cloud, but from the cloud back to on-premises as you need it. For on-premises storage, we support standard NAS type appliances, Windows servers, things like that, anything that tops the NFS or SMB protocol. We also support object storage systems that are compatible with the S3 API. And then we also support Hadoop clusters. So you can use DataSync to copy directly to and from Hadoop clusters using HDFS. DataSync also has a presence at the edge. So AWS Snow Cone devices, which are small form factor, Snow family, those physical storage devices, those come built in with the DataSync agent. So you can use DataSync to copy data directly from a Snow Cone device over the network up into AWS without having to ship the device back. You can also use DataSync to copy data between S3 buckets on outposts, like between S3 on outposts and S3 in region. And then finally, earlier this year, we added support for DataSync to copy to and from other clouds. So currently, we support Google Cloud Storage, and we support Azure Files, and we'll be adding more capabilities going into the future. But the key word here, again, as I talked about with on-premises, you can copy to and from on-premises. Well, it's the same with DataSync and other clouds. You can use DataSync to copy data from Google Cloud into AWS or vice versa if you need to. So DataSync is flexible in that regard. And then lastly, a lot of customers are using DataSync today simply to copy data between storage services within AWS. And we make this really easy for customers. There's no infrastructure to deploy. There's no agents to deploy. When you're copying between AWS services, you can use it to copy between S3 buckets, from an S3 bucket into an FSX file system, or EFS, any combination of those that we support, you can use DataSync for. And you can do that both within region and across regions. So super flexible for customers who might need this, to move data from one bucket to another, or maybe to, move data for processing data on a higher speed file system. Lots of use cases here our customers are using this for. And then finally, I just wanted to talk quickly about DataSync Discovery. So this is currently in preview. We launched this in September. So this is for customers who are looking for a little bit of help as part of their migrations, that first use case that I was talking about earlier. So DataSync Discovery was built to help customers gain better insights into their on-premises storage utilization. So using DataSync Discovery, it automates data collection over a period of time that you specify. As that data is collected, this is things like performance and capacity usage over time. We provide dashboards so you can view the data that's been collected and allow you to find things like underutilized storage resources. And then once those discovery jobs that have been running for a period of time are done, we then provide you recommendations for migrating your data into AWS. So, if you're looking to understand what would my cost be if I moved my on-premises NAS into FSx for NetApp ONTAP, for example, we'll provide you that cost and the recommended configuration for that that's optimized to meet your performance needs while minimizing costs. And then the way our customers are using this is primarily as part of their migration planning. So early on, they may need to understand what are the costs associated, like we were talking about, get a ballpark idea as they're planning migrations of what costs might be to move data into AWS, as well as validating the assumptions right before migrating. So making sure that, yes, what we've actually been looking at makes sense right before we start a migration. So this is in preview right now. It's available in the US East 1 region. It's free to use. So if that sounds something like you'd be interested in, definitely go and check it out. It's available in the AWS DataSync console, and it describes all the setup steps and everything in our documentation. Okay, and with that, I'm going to turn it over to Sam, who's going to do a deep dive on DataSync for you. So, Sam?
Thank you. Thank you, Jeff. Hello. As Jeff said, my name is Samuel Souza. I am a storage solutions architect here at AWS, and I will present the deep dive part of this session today. Before talking about in details about DataSync architecture and also some use cases, I would like to talk about DataSync components separately. The first one is an agent. What is an agent? An agent is a virtual machine that writes data to or read data from a storage system. And this agent can be deployed on VMware ESXi hypervisor, Microsoft Hyper-V hypervisor, and Linux KVM. One important thing that I would like to clarify is that an agent is not a software that you install on an operation system. Instead of that, one agent is a full virtual machine image. Also, if you need to copy data from or to a self-managed in-cloud storage system, you can also deploy a DataSync agent on an EC2 instance. The second DataSync component that I will talk about now, it is a location. Location, it is where you read data from or write data to. And you can have a storage system as a location or an AWS managed service as a location. These are the supported locations by DataSync. NFS, SMB, HDFS. You can also have an object storage compatible with S3 API. Amazon EFS. Amazon FSx for Windows file server. Amazon FSx for Lustre. Amazon FSx for OpenZFS. Amazon FSx for NetApp ONTAP, and also Amazon S3. One thing that I would like to clarify is that agents are associated with locations. I'm saying that because I will talk about tasks in a moment, and agents are not associated directly with tasks, but, as I have just said, with locations. When you are reading data from or writing data to a storage location, such as NFS, SMB, HDFS, or an object storage compatible with S3, you need to deploy an agent. When you are writing data to or reading data from an AWS managed service, you don't need to deploy an agent. This is a very good benefit. All infrastructure needed to manage and transfer the data is provisioned by DataSync service. Now, let's talk about tasks. Tasks defines where and how you are going to transfer data. So you have a source location, so where you read data from, right? You have a destination location where you write data to, and you also have task configuration. In the task configuration, you can define some parameters, such as file extensions that would you like to include or exclude from your transferring. You can include some folders or exclude some other folders if you need. You can also run a task on a schedule, so you can define the time and the frequency that you are going to run your task. And also another parameters, such as tags and also logging. A DataSync agent can run one task at a time. You can have one agent running more than one task, but not at the same time. Tasks can be queued if an agent is in use. So if one task is running with an agent, and you start another task that is also linked with this agent, this task can be queued. A task copies data from one source to one destination. It is a one-to-one relationship. A task can process up to 15 million files, but you can run more than one task if you need. Task can be configured to run on a schedule. As I said, you have to schedule a task, or you can run a task on demand. But DataSync is not transferring data all the time, only when your task is running. It is a very important concept. And there are some stages when you start a task. For example, the launching stage. In the launching stage, DataSync will provision all the infrastructure to manage and transfer your data. In the preparing stage, DataSync will compare the source location with the destination location to see the data that will be transferred. It is basically a metadata operation. In the transferring, it is the stage that DataSync will transfer the data. It is basically a data operation. And at the end, you can have the verifying. And here, you have some options. You can choose to verify only the data that you transferred, or you can choose to verify all the data, comparing the source with the destination. You can also maximize the available bandwidth when you are copying large data sources, right? So for example, here, you can have a NAS, a network attached storage, and you can partition your NAS with some folders as a source location. And in the destination location, you can have an AWS managed service with also 4 folders. You can have multiple agents, and one agent running per task. So you can have parallelism when sending the data, so you can maximize your bandwidth. There is another example here. When you have millions of files, so what can you do? Here we have a NAS, again, network attached storage, with only one folder as a source. As a destination, we have an AWS managed service with also one folder, one-to-one relationship. In that case, you can have multiple agents running inside one task. If you are using this approach, we recommend you to use up to 4 agents per task. Now let's talk how DataSync works, right? So agents are deployed close to the storage systems. You create the locations, and you create the task, and run a task. DataSync service will provision and manage the transferring. And one thing that I would like also to talk about is about the connection between the agent and DataSync service. I will talk in details in a moment about this, but here you have some options. You can have internet, and you can have a VPN connection, a direct connect connection. Having said that, let's talk about some DataSync use cases. The first one, it is on-premises transfers. And when we are talking about on-premises transfers, we are talking about this architecture, but I will talk this in details now. So here you can have a NAS or a Windows server. For example, the NAS storage, you can have an NFS export, SMB share. You can have also an object storage compatible with S3 API, or you can have a Hadoop cluster running HDFS. You have to deploy the agent as close as possible of the storage location, of the on-premises storage location. In the AWS side, you have an AWS managed service. And you have here the DataSync managed service, again, that will provision and manage all the transferring. And here, I would like to talk about the connection between the agent and the AWS managed service. There is a very important network concept that we call endpoint. And here, there are some options that you can use. The first option is if you can send the data over public internet, you can use a public endpoint. But if you need a more secure connection, you can have a VPC endpoint. So you can use a VPN connection, and also if you need a dedicated link, you can use a direct connect here. And to our GovClouds customers, you can also use FIPS endpoints. And now let's talk about the DataSync network path for on-premises transfers. The first here, it is the connection between the storage system and the agent. And it has to be a low latency and fast connection. So we have to deploy the agent as close as possible of your storage system. Here is the connection between the agent and the DataSync service that I talked about. And here it is good because DataSync is very optimized for data transfer. It has an inline compression. You can also use encryption. DataSync encrypts in flight with TLS 1.2. This connection here, it is AWS network. So the AWS network, it is a high-speed, low-latency network that will be provisioned and managed by AWS. Here you can also do some configurations such as security groups, but the majority of the work will be done by AWS DataSync. Now, let's talk about cross-cloud transfers. Now you can transfer data from and to other public clouds using DataSync. And one very important thing is that where you are going to deploy your agent. You have here the public cloud, the other public clouds. You have AWS cloud, and you have two options. The first option is to deploy the agent on the other public clouds. In that case, as DataSync sends data incrementally and also uses inline compression and detects sparse files, you can potentially reduce your egress costs. But if you decide to deploy the agent on AWS, you can also do it. Normally, this is a good option when you are going to use a VPC endpoint. Now, let's talk about in-cloud transfers. You can transfer data from an AWS managed service to an AWS managed service. In that case, there are good benefits that I will explain in a moment, but you can choose to transfer data within one region, so from one availability zone to another availability zone, or cross regions. And what are the benefits when using the transfers between an AWS managed service? The first one is that you don't need to deploy and manage infrastructure. The second one is that you can copy data between any service, for example, from FSX to EFS, from EFS to S3. You can copy, as I have just said, within the same region or cross regions. All traffic stays in the AWS network, high-speed, low-latency network, and all traffic is encrypted using TLS 1.2. So I talked about the architecture of DataSync in details. I talked about some use cases, on-premises, in-cloud, cross-cloud, and now we have the most exciting part of the presentation, a real customer use case that will be presented by Jeff Lee from Foundation Medicine. Jeff, the stage is yours.
Thank you, Sam. Hey, everyone. I'm Jeff Lee. I lead the cloud architecture team here at Foundation Medicine. So today I'm going to talk a little bit about who are we as a company, what do we do, one of the challenges we have, how DataSync addresses that challenge, and what's our eye on the future with DataSync at our company. So, who are we? Foundation Medicine is a patient-focused company. We provide comprehensive genomics profiling for cancer patients so we can recommend treatments and clinical trials, because we believe that every patient can benefit from this information to better inform their care. This is how we can collaborate towards improving cancer care today, tomorrow, and together. And one of the things that drives us at Foundation is how do we get this information into the hands of our patients as quickly as possible? Every minute counts. One of the things we identified is how do we move data from our on-prem into the cloud, and how we do it efficiently and quickly. So the next few slides, I'll kind of dive into that. So as I mentioned, we perform these genomics profiling tests. It's a lot of crunching of numbers, crunching of DNA. And all this data is being produced at labs. So samples come to our labs, and the lab devices produce all this data that we have to process. These labs run 24/7 in batches, one device at a time, what have you. The other part of it is that we're growing globally. So not only do we have multiple labs growing, and all of the lab devices are actually exponentially increasing the data set that they're producing, because as the lab technology grows and improves, the more data you get. So all of these things lead to some challenges that we're trying to address. Because the labs have to run on-premise, we have to have all the on-premise challenges we have, which are how do you store the data locally? How do you scale that storage? How do you scale the network to bring that data into the cloud? People, time to maintain all the on-premise infrastructure. Space, power requirements, lead time to source, all those exist for all our lab environments that have to run on-premise. The second part to these challenges are we need to have lab devices finish their run before we can begin processing. And I'll get into that a little bit later about why. Now, these lab devices run for 24 plus hours, so they take a long time to run and generate a ton of data, like tens of terabytes every day. So what have we done to try and bring the data from on-prem into the cloud? Well, we've tried large batch transfers. As soon as the device is finished, we go ahead and transfer it up to the cloud. That takes a lot of time because, again, lots of data. And if you're going to move it up after the device is done, it takes a long time to move it up, hours. Another path that we tried is parallelized transfers. At the point that the device is finished running, just suck up that data as quickly as possible. Just parallelize that transfer. But there could be a bottleneck with the network because now you're putting a lot of stress on the network bandwidth and the throughput. And both these paths, while they can work, if it's one device at a time finishing serially, what happens if multiple devices finish all at once? You can have a lot of bottlenecks. Or it can take a really long time to get that data up into the cloud. So what did we do? We built the data transfer utility at Foundation Medicine, DTU for short. At the core of DTU is DataSync as our data movement engine. We wrap DataSync with event-driven modular components. So we have a component that's a trigger component that's watching our devices. And it says, when there's a new run, let's let DataSync know there's a new run. The scheduler basically tells DataSync how and what are you transferring in this new run. And DataSync goes ahead and starts moving that data. We also have a monitoring component. And in this component, we're monitoring for success as well as error events. So we know, are we ready to process? Or does the operation team that get involved to bring it back? As I mentioned before, the lab devices take a long time to finish, 24 plus hours before we begin processing. And the reason for this, the reason why we have to wait for it to finish is that we look at data in two parts, atomicness and integrity. Atomicness to us means that all the data of an entire run is available to process in the cloud. The reason for that is that anything short of 100% of the data, that means that we cannot begin processing. It could fail. That might mean another 24 plus hours of lab time. That means 24 plus hours of a patient waiting for their information. So atomicness is very important to us. Integrity means what was produced at the lab device is indeed what's in the cloud, point A to point B. How do we ensure that? Together, we consider that completeness of data. Now, with this in mind, what we leverage DataSync for to address these two things is we basically use DataSync to run small batch transfers focused on the delta of the changed data into the cloud, from the lab to the cloud. What this allows us to do is to spread that data movement over the course of the 24 plus hours in these smaller batches. The way we ensure atomicness is that at the finish of a run, we launch one last batch transfer. That transfer basically kicks off, make sure that all the delta information is up there, and all the data is ready for processing. How we address integrity is that we leverage DataSync's checksum checking for data. And what we do is that we spread the integrity check over the course of the 24 plus hours too, because each batch not only does it transfer the data, but it checks for integrity along the way. This way, we're spreading the data movement and integrity over that 24 plus hour period of time. And that's how we ensure completeness of data, and we have the best chance of processing that data in the cloud. That's how we guarantee completeness in the shortest amount of time. It's how we get the information into the patient's hands as quickly as possible. So what has been the impact? Well, able to reduce our on-premise storage footprint, because now that we have DataSync to transfer this data into the cloud from point A to point B, as soon as we've confirmed it's a point B, we don't really need to keep it on-prem, so that on-premise storage footprint can shrink. Also, we can simplify our data life cycling, because in the cloud, once the data is up there, there's a lot of automation that we can do to life cycle our data. And because we're using smaller batches, means the network bandwidth doesn't have to burst so much. So we're just doing over time, a lower network throughput requirements, so we can reduce that footprint as well. From a business standpoint, we are able to reduce our turnaround time, meaning we can get the information to our patients' hands faster. An example of this is our global transfer time went from 24 hours, a giant batch transfer, down to 24 minutes. That's an extra 24 hours. Sorry, it's 24 hours less time that somebody has to wait for life-saving information. So what are we looking at into the future? We're not done yet. What we're eyeing on in the future is that DataSync as the engine of data movement for us, and all these module components that we've built around DataSync allow us to add new use cases to moving data from point A to point B. Some of the things that we're looking at is adding additional contracts for cloud-to-cloud data movement between accounts, and additionally, how do we help our researchers with data movement as well? Now, some of the features that we're going to look at pretty quickly is how DataSync can configure the bandwidth of a data transfer. And the reason why that's important is that as we try to reach out to more labs, not every lab site is created equal. Some lab sites don't have the enterprise network throughput that you might need. There are smaller labs, but we want to reach more patients. That means to reach to more labs. Using DataSync's bandwidth configuration, we can tune the bandwidth depending on the lab site, on how much pressure do we put on that network, but still be able to reliably and repeatedly bring that data from the lab to the cloud to begin processing so we can reach more patients. The last thing is accelerating discovery. Now, researchers tend to have larger data sets. In addition to that, they also like to collaborate, so they like to move data from here to there, run their experiments. So we want to look into how do we leverage DataSync and DTU to bring the data to the researchers so they can experiment faster. I want to take this opportunity to say it's been quite the journey with the DataSync team. We're excited for the future, and we're really interested in seeing what new features are coming out. And with that, I'll send it back to Jeff.
Cool, thank you, Jeff. Love the story. 98% time reduction results. You can imagine that if you've gone to your doctor and you've gotten a potential diagnosis of cancer, the last thing you want to do is sit around and wait for a long period of time. Every hour that's passing, you're like, I want to know my results. And so Foundation Medicine is helping their customers get those results faster. It's a really great story, so thank you, Jeff. Just to wrap up, some key takeaways. So remember that DataSync provides both storage discovery and data movement capabilities for migration, archive, replication, and hybrid transfer workflows. We support on-premises locations, edge locations, and now other cloud locations. We've got network endpoints that give you features for secure, fast, and reliable data movement. And we're able to maximize your available bandwidth. Sam talked about that, using multiple tasks in parallel to maximize your bandwidth and really copy large data sets. So to get started with DataSync, definitely head to our homepage, aws.amazon.com/datasync. We've got blogs, use cases, all kinds of good stuff there to check out. There's also some additional sessions focused on DataSync and data movement. Definitely check these out. These are happening later this week. If you're interested at all, definitely check out these sessions. And then finally, you can continue. If you're interested to learn more about AWS storage, you can head to aws.training/storage, or you can learn more about that, earn some AWS storage badges, and increase your knowledge. And with that, I just want to say thank you very much for your time. Very much appreciate it. Have a wonderful day, and we'll do QA over here if you got it. Thank you.